Hello, you join me mid-tinkering. I've been, over the last few days, I've been playing with an assortment of things. This is part of it. Let me explain. We'll start with the most familiar thing. On this breadboard, we have a 555 timer, happily blinking away. That output is going over here to a 4988 stepper driver, which is driving this stepper here. And then over here we have a relay, which is basically connected to these two micro switches, which are acting as limit switches, which can change the direction of this motor when it hits its limits. Now, the first thing that I want to acknowledge, because I know somebody's already typing it, yes, I could have done this with a microcontroller, but I don't want to. I want to go back to old school and do this the way I have been thinking about electronics for decades now. Anybody who's been around here for a while knows that I don't enjoy coding, so when I can avoid it, I'm willing to do an entirely hardware project. So that is what this part is. It's fairly straightforward. Each thing on its own is a simple little block. The 555 we've explored many times before, and I can vary the speed of it right down there or up nice and fast, and of course that reverses. I could also, on the 4988, set it into micro-stepping mode. I don't have it set there right now, just for this experiment, but I could micro-step it if I wanted to, and I may yet do that later on in the project. But this is only the electronic part of the project. The other part of the project is mechanical and involves some 3D prints and various other bits and pieces. So you may have noticed that I have a gear on there, a pulley I guess, for this timing belt, this stuff. So that is that part. I 3D printed a pulley to go with it, which works, but was a bit of a mistake. And I 3D printed these end pieces that slot onto the 2020 extrusion. This one was the first experiment, and it was undersized. So I printed this up for a piece of rod to go through. I designed it to take some of these what are these, 806 bearings? No, 608. What are they? Yeah, 608 skateboard bearings. And then I realized that I don't want this thing to pivot on a swivel. I want it to be driven by the belt so that this entire thing moves when the motor moves the belt, like that. A big, long, cantilevered thing. Then I'm going to put this ball head camera mount onto there. And for that, I am going to use my mistaken piece of 3D print because, well, it'll do the job and I don't want to have to redesign something else. So that will go on there. And then my little sports camera will mount on this on the bottom. So what I'm intending on doing is having the motor and the gear and the pivot mount back there and have this little camera mounted like this, kind of pointing down towards the center of the bench. And then having it just sweeping around like this, just quietly in the background, above the shot that you guys see normally, just to give me another view and something that I can use in time lapses. And I'm hoping that if this is smooth enough, that this video will actually be usable. I could also use exactly the same mechanism on a linear rail just to slide a camera this way, and that is something that a lot of people do just for a nice tracking shot or something like that, but I don't really have enough room to do that, so I was thinking of doing this little orbiting shot up there. The only thing that I haven't worked, well, there's a lot of things that I probably haven't worked out yet, but one thing is, I guess, how to mount these, probably like that, so that at about 180 degrees from each other going around that way, these switches collide into it and reverse the direction of this. But that is something that I'll deal with later. What else have I done here? Oh yeah, I printed a little cage that this guy goes into. I'm hoping, well, a couple of things that I'm hoping. One, that it'll grip onto there well enough, and two, that the motor doesn't get so hot that it deforms this, because that is a distinct possibility. Anyway, I'm going to start building this thing up. These are going to mount on here just with some M4 and T-nuts. That's the kind of T-nuts that I'm going to use. And then I'll run the rod up through it, measure it, cut it off, and carry on. Well, you'll see. I don't think I'm going to time-lapse this just because I have to go here and there. I'll pop in if I have any trouble. Otherwise, I'm just going to go ahead and you'll see it when the mechanical bit is assembled and I've got another problem to solve. Remember those M3 grub screws that I got in the last mailbag from my anonymous donor? Remember how I said they were going to come in handy for an upcoming project? Thank you once again for the donation. Alright, so here's how these parts stack up. I've got the threaded rod coming down through here, held on up there. Put a couple of washers on just as spacers. Then there's this little bearing block with 2 bearings in there. That goes through the wooden plank. I'll screw that down in a bit. And this holds it all tight together, because the part that rotates is the part above the bearings. Now let's just see. Oh yeah, that's smooth. That's excellent. Except for I put the camera mount on upside down like a big dummy. But other than that, it seems to work well. Okay, I've just got it mounted up there temporarily to make sure that I've got clearance, and I do. But here's kind of the idea that I'm going for. I think you can see, it's kind of backlit, but yeah. So the camera's kind of pointed down, and I think I'm going to have to point it a little bit further back. I probably am going to need a longer piece of aluminum extrusion ultimately to do this permanently, but I'm thinking that if I can get that kind of shots, that's sort of what I'm going for. And it fits up there, so next to mount the motor on it and figure out this last part, and then probably the easiest part will be committing this mess here to a circuit board. And perf board, obviously. I'm not going to burn off a board and send it off to China just for that. But yeah, that should be, like I said, that'll be the part that I'm most confident about. It's this mechanical stuff that always throws me for a loop. So with that mounted on there now, the next big challenge is the tedious process of designing a little mounting bracket for this. And I think we need them to sit at about a 45-degree angle so that kind of works. So you can probably find dimensions of standard microswitch holes, but because I'm lazy and don't want to look, I'm just going to measure it myself. That is 15.7. Time has passed. I got these little brackets for the microswitches printed up, and I realized that I needed a mirror image, not two the same, so I had to mirror image it and print another one. So another scrap part. So as you can see, I've got them mounted up, and when this guy swings, it hits the 2 limit switches before it crashes into anything else. I had to adjust this one a little bit because initially it was crashing into the motor frame, but now we're all good on that. So the next order of business is transferring the control circuit over onto a perf board. And I've been working on that quietly behind the scenes. Didn't think you guys needed to share all my frustrations, but I'm getting close. I still have to do the 555 circuit, but I should be able to run it now. I think if I just move the relay over, and that should plug into there, and then I will plug in. I'm going to leave that one over there. I'll plug in the module here, the stepper controller module. Just got to make sure that I got the pins on the right and the correct side. So the board so far, as I said, I've got the stepper controller there, the reversing relay there, 555 timer there, 5-volt regulator, capacitor on the 5-volt line just so that the control signals don't get messed up. These 3 dip switches are connected to the microstepping control inputs on here. Microstepping basically means instead of the stepper motor going, 1 step per pulse, it can go a half step or quarter step or an 1/8 or 1/16 per pulse, which means you get a lot less jerky motion. And these 3 control lines are what are connected to those 3 dip switches. And then we have the 2 the 2 controls. We have the step, so for each pulse, each square wave pulse that comes to this step input, it moves the motor 1 step or 1 microstep, depending on how it's set. And this direction is just a high or low, 5 volts or 0, which determines which direction the motor rotates. And I guess while we're talking about circuitry, let's just have a quick look at this reversing relay setup. So we have the relay here. It's a double pole, double throw relay. So 2 switches inside it. Each one has 2 positions. And then we have the 2 micro switches up here that are acting as limit switches. So 1 set of poles on the relay acts as the reversing signal going to the stepper controller. That goes to the direction. We have either 5 volts or 0 volts. So binary high or low, basically, going to that to select the direction. Then the other half of the relay, the other set of contacts, acts as the latching. So when it powers on, it's in the state that it is shown here right now. So not magnetized. This switch is in its open position, so nothing's happening there. And these switches are both in their normal position. So with it like this, the direction will be sending the arm this way. When it crashes into this switch, it flips the switch, sending 12 volts down here and energizing the relay coil, which pulls the relay in, which then sends 12 volts to the coil through this switch as well. And that holds the relay on until the arm comes back here and bashes into this switch, which opens it in this case, which removes 12 volts from here and drops the relay out, causing the direction to switch again and us to continue back this way. And it just keeps repeating like that. Click, click, click. And again, as I said at the beginning, I didn't feel like doing programming. I wanted to do this old school. So here we are. Now, all I've got left to do on my little circuit board is put in the couple of resistors and the capacitor for the 555. And it should be good to go. Also, you may be able to hear the 3D printer running in the background. I discovered when I was hanging this thing up earlier that, and I should have noticed that earlier, that this motor holder doesn't have any way of holding the motor from coming this direction. It's just jamming on the wires down there, and that's the only thing that's stopping it from falling out. And of course, this thing is mounting in this orientation, so it's probably going to put stress on the wires and cause it to be overcome by gravity. So I've modified this slightly to put little pieces across the corners just to hold it in place, and I will, when it's finished printing, I'll replace this. But for now, I can continue on like this. That's only 4 screws to replace that, so that's nothing serious. Right, I'm going to carry on messing around with this, and I'll come back to you in a while. Okay, time has passed. I've got the board, I think, all good. I've got the switches wired up and everything. I don't have the driver in there yet. I just want to do a bit of testing and make sure everything is where it's expected. So turn the power on, and we're not drawing excessive current, so that's a good start. Now then, there should be voltage there, yes, and there should be voltage there, brighter voltage, 5 volts and 12 volts, that's good. There should be voltage there on the 555, yeah, and the 555 should be pulsing? Yes, it is. And now where is... Okay, so that is also, that's the steps from the 555, so that's good. Cool, that works. And then this one should be the direction switch, which should... Perfect. So I think that's all I'm going to need to get it working. I've got voltages where I need them to be. Oh, yeah, this thing that I was printing, the printer is finished, I think. So we'll just break the supports out of this thing and get it off the build plate. And, ooh, that's really stuck down. Anyway, I'll do that and I'll be back in a second. There, I think that ought to hold it. So I'll just quickly yoink this thing out and replace it, and then we'll carry on with testing because we're getting close. I think I should be able to power this thing on and mount it very, very soon. There, that looks like... Uh-oh, I'm going a little tight on it there. Oh, I think that's going to do the job anyway. And if it doesn't, well, I'll modify the print and print another one. Meanwhile, what did I have left for testing? Oh, right, just the driver board. Let's grab that and make that happen. Make sure that I've got things on the right side there. There's the motor outputs. They go to this side here. So, if I power this thing on, what I would hope to see happen is this starts moving, and I'm hoping that it starts moving that direction. Power. It is going that direction. So what is happening when this hits here? Oh, okay, that's all. I think I just have to bend the switch arms out. I think what is happening is that it's not, it's crashing into the body of this thing before it gets where it needs to go. Okay, that's an easy fix if that's what's really going on here. Yeah, let's try that now. There we go, that's all it was. Okay. I think I do need to put in that micro stepping though, because that is far too jittery. Let's try just the first micro stepping. That's better. How about the second one? That's not exactly what I had in mind. I'm going to have to do some thinking about this. I'm not quite sure why that is. So since I'm this far, I decided to install it anyway, just to see what it would do. And yeah, that's not great. The other thing I've discovered is that it's bouncing up and down a lot at the end of that long cantilevered arm. That's going to be completely unusable footage. Though the reversing mechanism does work, so I guess that's something. I don't think that's going to be usable with a stepper motor just because it, steps. May have to do some rethinking on this and maybe come up with a DC motor solution. But I suppose I can just unpower it for now and just use it as a camera holder and put it wherever I want it and give it a nudge every once in a while so it's in a different spot now and again just to vary things. If you've got some experience working with stepper motors and these 4988 modules and how to get them to do smooth motion, I would like to hear from you down in the comments. I'm going to do my own research, of course, but I think I'm going to leave this here. So after giving up on the stepper motor design, I've been experimenting and trying a few other things, like this motor that I had lying around. You know the one, it's the same motor that shows up in all of those Arduino starter kits. Unfortunately, it has way too little torque to move this thing. It just sits there and stalls and slips its internal gears. So that ain't gonna work. So I'm going to continue tinkering away off screen for a while. I'll be back with this project again in the future, but I've got to order some stuff and track down some torquier yet slower motors, smoother motors, and come up with a way to drive them. I think I've got it here, more or less, but without the motor doing its thing, then there's not much else I can do with that right now. Anyway, stay tuned, and yeah, as I said, I will be back to this at some time in the future. I did learn a fair bit, though. I got some practice in 3D modeling and making some custom pieces. I even made up some spacers for the for holding the circuit board because I didn't happen to have any. So I guess there's a win there. I got some experience with that. Spent a few evenings tinkering with this thing. Ultimately, it didn't work the way I wanted it to, but I can still use it for some stuff. And yeah, I guess that's everything for now. Thanks for watching. Sorry for the disappointment at the end, but sometimes that's just the way it goes. Thanks for watching. Comments and questions down at the bottom. As always, I'll talk to you later.